everybody, and welcome to the XR Enablement Track. I'll be your track chair today. My name is Louis Normandin, the COO of Wild Capture. We specialize in digital humans for interoperable technologies across the space. Today we're going to have an excellent presentation from the team here at AWS. We're going to be working with spatial computing today, and we've got some awesome professionals here to tell us how it's done. Kimate Richards and Heidi Buck from AWS. Thank you so much.
Hey, thanks for the good intro. So I'm Heidi Buck. I'm a senior manager for spatial computing at AWS, and I'll be joined a little bit later by Kimate Richards, a senior solution architect for strategic accounts at AWS. And then, of course, we'll be joined by Spot, the robot, who I'm sure you're all here to see today. Now, I had practiced walking around on this stage, but I'm going to trip, so I'm going to stay over here. It's not worth it, right? So there we go. There's Spot. So a bit about me. I've been at AWS for only a year now, and I run a spatial computing prototyping team. And prior to that, I was 20 years with the US Navy as a US Navy civilian, running innovation programs for a Navy research lab in San Diego. And in fact, that team is here today. Can I get a hey from the Navy team? So my claim to fame is that this team right here put a DAQRI headset on a sailor on board a US Navy warship. We did a live fire exercise with the DAQRI headset, and then we built a VR simulation around that, brought Palmer Luckey into the lab, and he did that VR sim. There's a picture of him. So I'm going to talk to you about three things today. What is spatial computing to AWS? I'm going to bring it back to the title of my slide. I'm going to talk about 3D and the 3D data collection pipeline. And then I'm going to do a really cool demo with Spot the robot. So I wanted to start off with a show of hands. How many people actually use the term spatial computing? Oh, it's more than I thought. Okay. So I had never heard of it when I was interviewing at AWS, and I'd been in immersive tech for 8 years at that point. I'd never heard of spatial computing, and I was interviewing for a senior manager for spatial computing jobs, so I had to Google it. My boss is out there. So I had to Google it. So one of the things that I did when I first started at AWS is I made a little movie about what is spatial computing to AWS. We don't think, oh, it's playing, good, there's no sound. So there's dialogue over this, so I think I'm just going to skip past it since we can't hear the dialogue. But it's a nice little movie about what is spatial computing to AWS, and I posted on LinkedIn. So what the video says is that we believe, AWS believes, spatial computing is the technology that powers the blending of the virtual world and the physical world. And what it is it combines 3D data with location. And in practice, there's a number of technologies that feed into spatial computing. In fact, I recently published this diagram on our spatial computing blog. This is called the Spatial Computing Spectrum. It was dreamed up by a couple of my colleagues here in the audience, and it attempts to describe all of the different tech that feeds into spatial computing. And so what we have is on the left-hand side of this spectrum, we've got technology that resides more in the cloud, that's more virtual. So think software, packages, tools, so 3D simulation tools, AI/ML tools, 3D CAD software packages. On the right-hand side of the spectrum, we have technology that is more grounded in the real world. Think robotics. Think also, the reason why digital twin's on here, think the actual digital twin of the actual smart factory. So then, all of this technology is what powers the metaverse and all of these cool metaverse experiences that we're building. So, at AWS, we believe AWS is the best place to build these spatial computing experiences. And in fact, we've adopted these 4 pillars for spatial computing enablement. So the first pillar is infrastructure. So we believe that AWS strives to have the widest and deepest set of building blocks. So building blocks, think services, think compute, that would help enable spatial computing experiences. The next one is open standards. So we strive to reduce cost and increase efficiencies for our customers by relentlessly promoting open standards, open interfaces, and being device agnostic. And then people. So can I get the hey from AWS people here?
Yeah!
So we are silver sponsors of this event. We're out in force today. So great spatial computing experts here today and at the rest of the company, and of course experts in cloud computing as well. And then partners in tooling. So AWS focuses on providing a broad ecosystem of partner and AWS solutions. So it gives our customers a choice. Speaking of partners, great list of some of the folks in our partner network. Got 2 slides here, and a big thank you if Immersal and Hexagon and Leica are in the audience. Big thank you to those guys today, because Spot unfortunately arrived without a charger, and last minute, right before the talk, we were charging Spot up with one of their chargers. So we appreciate it. We love our partner network. I've got the link to the partner network, QR code there, if you're interested in learning more about it. So my team at AWS is in an organization called PACE, Prototyping and Cloud Engineering. So we empower our customers to innovate faster, think bigger, and our goal is to help our customers bring their big ideas to life. And so PACE is geographically aligned. Anywhere in the world, there are prototyping teams available to help customers prototype. However, my team is focused on spatial computing in the North and South America region. Now, so what's a prototype? Everybody has a different definition. Well, a prototype to us is more than a proof of concept. It's less than a pilot. So it's weeks of build time. So we typically say 6 to 8 weeks of build time. During our prototype with our customers, we can build with the customer, we can build for the customer, and what we might build could be a full stack solution for any subset of use cases. Now, PACE is an investment program in our customers. So we invest in our customers. We help them bring their big ideas to life. And so how we are investing in our customers is we are providing the prototyping experts to our customers. We are providing the AWS services to our customers, both at no cost to our customers. So, this is great, right? However, there's only so many prototyping architects at AWS, only so many prototyping teams. So we have an engagement intake process. We have to qualify all of our engagements first. Now, all customers, all prototypes might not qualify for an engagement, but what we do is we encourage our customers to work with their account managers to learn about all of the different options available to them beyond prototyping. All of the different services, groups, processes out there that can help them on their spatial computing cloud journey. So, I've got my call to action right here. Not done with the talk, but I think we're going to get a little distracted by this robot in a few minutes. So I've got my call to action right here. If you're interested in learning more about spatial computing at AWS, check out our blog, linked there, QR code there. But again, talk to your account manager. There are so many interesting options available to you to help you on your cloud journey with spatial computing. So that's our call to action. Now, second topic I wanted to talk about. Werner Vogels is pictured here. He's the CTO of Amazon. He said at a recent reInvent conference that 3D is soon going to be as pervasive as video. So I want to bring this talk back to 3D and the 3D data collection pipeline. So this diagram that we have here is what we would call the ideal 3D data collection pipeline on the cloud, powered by a number of different AWS services that I'm going to talk to you about in a second. The first step in that pipeline is obviously reality capture, because you got to go get data, you got to go get a 3D model to start with. So obviously what we're going to talk about is using robots and drones to go capture that 3D model data, to go image those facilities. And ideally, you would use robots remote controlled by, powered by AR devices. And so that's the demo we're going to show. We're going to have Magic Leap glasses. We're going to be powering the robot up on stage here. The next step of the pipeline, you got that imagery from the drone, you got to process it. And so I'm going to talk to you about a prototype my team did, where we enabled fast, scalable, cost-efficient, secure cloud processing of that imagery to create that 3D model. The next step in the 3D data pipeline is the storage of that data. So I'll talk about another team and a tool called VAMS, Visual Asset Management System, that enables reliable, easy to operate cloud storage. And then the last step, you got to do something fun with all that data, so you got to make your digital twin with the data. So I'll talk about AWS's IoT Twin Maker and how we can make digital twins easily. And in fact, the talk right after this is going to be Jonathan Kyle, and he's here to also talk more on IoT Twin Maker. So let's talk about processing, because we're going to save this for last. So step 2 in the pipeline, this is a prototype my team did. It was an engagement with KCI Construction Company. They are a full-service general contracting company. What we did is we implemented capturing reality software on the AWS cloud. So we built a web interface. You can kick off jobs, you can manage jobs, process your data, view your data, all in the cloud on AWS. Now, the cool thing about this, prior to this prototype, KCI was spending 2 days processing locally on a graphics workstation their 3D data to create 3D models of a single construction site. And so after this prototype with KCI, they were able to free up that graphics processing workstation and process a single site model in minutes to a couple of hours. Now that's cool, but the extra added benefit here is now they can process multiple site models at a time, all on the cloud. Again, freeing up that graphics resource processing workstation for other important work. And they can do that all for, in this example, under $10 of compute spend. So we were able to improve processing speed, and we were able to reduce processing cost for them. So it was a big game changer for them. So the third step in that pipeline is that 3D file storage. So I mentioned there's another prototyping team, spatial computing prototyping team that we work with. They created visual asset management solution system. And so this is an open source solution. So if you go to that QR code, that link, it takes you to our blog site. It takes you to the VAMS article, which will then point you to our GitHub page. You can download this software as well. But what VAMS is it's a way to upload and manage your 3D assets. You can visualize everything in 3D. You can visualize it in VR. And then the cool thing about VAMS is it allows you to build your own workflows. So now you can build special workflows to transform your data any way you might need to. And then last is the digital twin, AWS IoT Twin Maker. We're going to have a talk about it in a few minutes. But it's a way to view your digital twin and overlay IoT data with it. So with that, Kimate's going to come up. We're going to start our demo and talk about the reality capture piece and the robot.
Thank you. Thank you. Sweet. So now we're up to the most arduous part of this is actually a live demo. But first I want to thank a few people. A couple of names are not on here and none of our faces are on here. I'll start with myself. My name is Kimate Richards. I'm an AWS Solutions Architect. A lot of folks in the room have helped us out. I want to single out a few people. John Saminsky, sitting in the corner over here. So he is the Spot Wrangler for AWS. So he has that kind of distinction. And then I also want to point out the Wonder Twins over here. I'm sure you've heard that before. Adrian and Christian, they're from Magic Leap. And without this partnership between Magic Leap and AWS, this could not have happened. So I really thank you both. And Roger Kinney, who's our UX expert, who can't be with us today, unfortunately, he's stuck in New York. But this was a pipe dream of mine maybe 3 or 4 years ago when I thought, hey, robots are going to become a thing. And they're going to be in our daily lives. They're going to be in your homes, your Roomba, your Tesla, those kinds of things. And at some point, they're not going to be completely automated. They're going to be partially automated, and it'd be better for us to have some control when we needed to have that bit of control. And then I started thinking a little bit bigger. I said, well, if we can do this in our homes, we can also do this in oil and gas pipelines, in other areas, airports, and shipyards. We can have humans and robots working together seamlessly. And one of the best ways to do that is through some kind of AR control. So obviously we're headed toward this world where we have all of these new devices, all of these new things coming up. We're going to have personal transports. We already have the Amazon Astro, if any of you are lucky to have one in your home. And then we all know about ChatGPT. These kinds of things are great for our lives, but also they're not fully fleshed out, they're not fully formed. And the best way to control all of these different environments is with a human. And that's why, and if you've heard of ChatGPT hallucinating, that's one of the reasons why a human's in the loop, is because we can't quite trust a large language model yet. So we partnered with Magic Leap because we saw Magic Leap as just a groundbreaking headset to put together an environment where the robot can be sometimes autonomous, the IoT system can be sometimes autonomous, but when we need human control, we can go and get that human control as we need. Quick plug for AWS and Amazon. We have lots of robots. At Amazon, we have, I think, over 600,000 robots at this point. And a lot of the packages that you get, a lot of the things you purchase, have been touched more by a robot than a human. And in this case, you're seeing our last mile delivery, something that we're working on. So these are publicly available images you can kind of check out for yourself. We don't have any drones overhead of this area, but we have drones in the sky already. So that's something to think about. And then we have a partnership where we're working on last mile with robots with arms. Yeah. So I've been told to speed through this. Because I get to demo. Okay, so robots. We have robots. Lots of robots. All right. In the partnership with Magic Leap, one of the most important things to me when I was choosing a headset was that I wanted a headset that was built on open source tools. So the Magic Leap 2 is running on Android OS. It allowed us to do a lot of different things, including ROS, if you're familiar with ROS. And someone clap for ROS? Yeah. Okay. And then high processing power. That's one of the things that's really important. So a lot of times you're not going to be connected to the internet. As much as we want you guys to all use cloud, there are going to be a lot of components that are going to be necessary to be on the device, like hand tracking, eye tracking, etc. IMU. And so it was important to have a device that had that compute capability. And frankly, it's easy to use. I'm very impressed with what has been done by the Magic Leap team. They're not paying me to say that. But I'm very impressed, and I've used all kinds of headsets. And then Boston Dynamics Spot, we use Boston Dynamics Spot in our own facilities with our own clients. And it's just a great platform to demonstrate what I'm about to demonstrate to you. But think of this as a bigger picture than just the glasses and the Spot today. Think of it as you're walking into your insert, whatever you're walking into, big warehouse or whatever it is, your construction site, and now you can put on a pair of Magic Leap glasses and use AWS, and then in the process control more than one item. So we have one item today here, but we literally have hundreds of robots running around here and in an automated fashion, and then control the one we want to control when we want to control it. A little bit more AWS icons, don't worry about it. The important part for today is we've implemented one flow for you to see, but we have hundreds of permutations of things you can do in AWS. There are 200 plus services at this point, and all of them are applicable to this situation. But I'm going to show you just a brief one, and that's basically the Spot in Magic Leap interaction using AWS. That big orange thing is probably the most important. That's called an AWS Lambda, and it's used to build functions in AWS. But like was mentioned before, you can plug in anything into this system. IoT Twin Maker. We have something called RoboRunner, which orchestrates bunches of robots together. We have VAMs, and the VAMs co-author is sitting right there. So if you want to ask some specific questions, go get him. And then this is kind of shown before, but just to demonstrate what's happening here, we use both of these tools in order to bring this to life. So that all being said, I'm going to stop talking and hopefully there's a demo. No one said woo for a demo? Can you see back there? No? 1 second, please.
And our plan is to walk Spot around the showroom floor after the next talk. So we'll walk him outside,
Yeah.
walk him around for folks to look at.
And likely tomorrow, you'll be able to actually do this yourself with the Magic Leap on during the expo. Okay. Oh yeah, you want to check out my code? That's cool, yeah. Okay, so 1 second. Lost ML Hub. So while this while Hub's getting started, I'm going to actually log into the robot and get started because we're running out of time. We only have 4 minutes left. Your overtime.
Yeah, that clock is...
Oh, the clock is wrong. All right, well,
We'll give you a chance, just if you got it ready, let's see.
yeah,
it, you know.
okay, sure.
I'm sure that's what everybody came here to see. Some fun stuff today.
I wish you guys could see what I'm doing. It'd be more fun than. So moving the hand controller. You got it. All right, awesome. Actually, the 120, that stopped. It all stopped. Yeah. Thanks. All right, so what's happening, and you won't be able to see it, unfortunately, is I am, and you'll be able to do this on your own outside at some point. What I'm doing is logging into the Spot, and what you'll be able to see once you're able to see this for yourselves, the Spot is going to start transmitting stuff to me. It's going to start telling me how it's doing. I'm just going to unplug that because it's useless. It's going to tell me how it's doing, and then it's also going to kind of continue on. And so right now it's loading up. It's going to start up. So it's starting up. And you'll start to hear it whir and make a lot of noise in a second. And while that's happening, I'm going to try to get the screen back. All right. So what I'm doing, I have an interface that I'm desperately trying to show you guys, so it'd be more fun to see on the interface. But I'm able to control the entirety of the spot using AR. So at some point in the future, you'll be able to say things like stand, sit, look right, look left, and the spot's going to go off and do what it is you told it to do. See, I don't know if you can see it twisting and different things like that. Yeah. So what I'm doing is I have a visual interface in front of me that you'll all be able to use outside. And I'm also able to see its cameras, and right now I'm looking at every camera that's going on up there. What you're seeing is the camera feed in bits coming out on the screen. But I encourage you all, since we're over time and we're getting kicked out of here, encourage you all to try this out. We'll have this right outside, and then further along we'll have it during the expo tomorrow. So thank you.